Hello there. Today I want to share with you a very interesting math problem that looks a bit complicated at first, but with a little bit of creativity is actually quite simple. And the question is asking, what is the 64th root of 2 plus 1 times 2 squared plus 1 times 2 to the power of 4 plus 1 all the way to 2 to the 32nd power plus 1. We multiply all that, we take the product, and we add 1 to it. And then we want to find the 64th root of all this. At first glance, it does seem to be a little bit complicated, but just wait and you'll see that it's actually very, very simple. So here's our problem at the top, and at this point in the video, I would actually encourage you to pause the video and try to figure this out on your own and see if you can solve it. Actually, I've numbered all the steps in the solution in the video, and I would encourage you to leave a comment saying at which step you got it and you were able to solve it. If you were able to solve it just by looking at the problem and working on your own, then say you got it from step 1. Or if, like one of the friends I showed it to, you got it later and needed a bit of hints, then maybe you got it at step 2, step 3, maybe even step 6 or step 7. Just leave a comment saying when you got it, and let's see what your thought processes were. I would be very interested to find out. But yeah, try to figure this out on your own, and if you can't, or if you just want to enjoy the show, then here's one way to solve it. The first thing we want to do is we want to multiply 1 in front of this product, because 1 multiplied by anything is just itself, right? So these two are perfectly equal. Now you might wonder why we would want to do this. And the reason is actually not 1. The reason is because we want 2 minus 1, which is equal to 1. And if you're acute, you would have noticed that 2 minus 1 and 2 plus 1 multiplied together, it actually fits the formula a minus b times a plus b, which evaluates to a squared minus b squared. So what this means is that 2 minus 1 times 2 plus 1 is equals to 2 squared minus 1 squared, which would just be 2 squared minus 1. And so we can substitute this product by 2 squared minus 1. And the rest are just the same. Now, what happens is we've noticed that 2 squared minus 1 and 2 squared plus 1, that's another a minus b times a plus b, right? So we can once again have this, which is the same as this, and we can change it to 2 to the power of 4 minus 1. And now we have 2 to the power of 4 minus 1. But, oh, it's another a plus b times a minus b, right? And if we look at the original equation, this is just 2 to the power of 1, which is equal to 2, right? If we look at the original equation, we'll see that 1 to 2, it's doubled. 2 to 4, it's doubled. And so we know that every single time the power over 2 is doubled. So here it's going to be 8, 16, and then 32. And so what happens is when this becomes 2 to the power of 8 minus 1, the next term here would be 2 to the power of 8 plus 1. And we would just simply apply this equation over and over again. And we would just have this, the power of 2, doubled each time. And so hopefully you'll see that what happens is if we keep going, we're going to reach 2 to the 32nd power minus 1 and multiply by this and add 1. And we do a minus b times a plus b once again. One last time, we'll get 2 to the power of 64 minus 1, and then we add 1, and these two cancel out, which leaves us with this, which obviously is just 2. And so after all this, we've simply reached an answer of 2. So here's our original problem, and the answer is just 2. Pretty elegant, right? I hope you enjoyed this problem, and here once again is the whole process of solving it. And yeah, do leave a comment on what you thought about it and which step you got it. Thanks for watching.